One of the skills that's going to be worked on in this unit is writing equations from a given bit of information, often kind of in a word problem type format. So the first thing to do is to read the situation. So to ride in a cab, there is a fixed rate of $2.50 and a cost of $1.75 per kilometer. Then you need to ask yourself, is there one of these two values that is going to depend on another thing? If it's going to depend on something else, it's likely the value that's going to go with your variable. So in this case, I have a fixed rate of $2.50. That's not changing regardless of what the situation is. Whereas it is $1.75 per kilometer. So that's the thing that's going to vary. So if I were to write an equation for this, I could do something like C for cost is equal to $2.50 plus 1.75. You can use X, you can use N, the variable is whatever one you wanted here. So you can write an equation that looks like this. Then it might further on and say, like, if you rode in the cab for 13 minutes, what's the cost going to be? So in order to figure that out, you're going to write your equation once again. And except this time, you're going to specify that you're telling me that N or whatever your variable is going to be 13. So you're going to replace that into your equation. So you're going to have 2.50 plus 1.7 multiplied by 13. So just as a note, this is a multiplication right here. So this is going to become $2.50 plus $22.75. And then at this point, I'm going to add them both together to figure out what my final cost for my ride is. So the cost in this case is $25.25. So one good practice to kind of get into could be to write a summarizing sentence at the end. So you could say, like, the cost of a 13-kilometer ride is $25.25. Something that could be kind of useful to do. Another thing you might see would be a situation similar to this. So you might also be given something like an airplane is at 1,500 meters in the air. It is going to land. And you might be given a chart like this and then asked to kind of look at it and see what are you noticing. So I would advise you look at each of the two columns separately. In past years, you would have seen these labeled as X and Y. They technically still have the same kind of roles. They are just going to be labeled differently depending on the situation. So here, you're going to notice that it's going to go up by 1 each and every time. And that's going to continue from there on out. Whereas here, you're going to notice it's going to be going down by 300 each time. So those are two things that you might want to kind of keep in mind when you're writing an expression or an equation. So in this case, where I'm noticing the values going down each time, that's something that I'm going to need to take into consider when I'm writing it. In this particular situation, since I know at 0 minutes, it's at 15,000 square feet, or 15,000 meters in the air. So it's 15,000, and I'm going to subtract 300x from this. Does it have to be x? Nope. But in this case, it is. This is an expression because I'm not necessarily saying what it's equal to. In this case, if I were to switch it into an equation, I might put something like height is equal to 15,000 subtract 300x. At this point in time, you could be asked to do a bunch of different things here. You could be asked, like, how high is it going to be after 15 minutes? Or how long is it going to take to land the plane? So if you were to ask how long it's going to take the plane to land, you need to be aware of the fact that when the plane has landed, the height of the plane is 0, which means that this column right here, the value is going to be 0 whenever that happens. So I can take my equation that I've written here in this situation, and I can put 0 in as my value for h or whatever variable you put in here. So that is 0 is equal to 15,000 subtract 300x. Like all my other equations, in order to solve for my variable, I need to have my variable on one side of my equation and my numbers on the other side. In this case, I could technically move either one, but I'm going to move the subtracting 300x, if only just to avoid negative numbers. I just find them easier to deal without. So I'm going to add 300x to both sides in order to get rid of it on the side where I don't want it to be. So when I've done that, that is going to be gone. And I'm going to be left with 300x is equal to 15,000. At this point in time, I'm just looking for the value of x, not 300 times whatever x is. So the opposite of multiplication is, of course, division. So I'm going to need to divide both sides of my equal sign by 300 to find out how long it's going to take my plane to land. Once I do that, I'm going to find out that it takes my plane 50 minutes to land. And similar to the one previous, you could often end it with kind of a phrase like, it will take the plane 50 minutes to land. Okay, so that's just kind of a good practice. It shows that you know that you actually answered the question that you were intending to answer. These are just two examples of many, many different options that you could have in these types of scenarios. So hope this helps.